What is known? The integral of the function is the area of the surface. Vector calculus theorem. The device is a planimeter and the measurement consists of a contour in a regular figure.
Explaining the problem. The method used by the planimeter should aim to get each dimension of every single area that you want to measure. Obviously, it needs to be as quickly and efficiently as possible. It is very important to clarify that our objective or goal is to discover how the planimeter works. Backing up the assertions. Based on the things that we have learned during the semester, in addition with the data that the problem gives us, we got to the conclusion that we need two mathematical statements to solve the problem. The first one is linear integrals and the second one is vectorial calculus. Also, we have discovered that the planimeter works with the next formula. A is equal K times L, where A equals area, K equals map scale, and L equals the average measurements that have already done with the planimeter. Proposing a solution. With the knowledge that we have just acquired, we are going to make a methodical explication of how math and vectorial calculus are involved to make a precision measurement with this instrument, developing a simple example and explaining it.
What is needed? The theorem relates with the device which is used to measure the surface, and how does the device work.
The planimeter is based on Green's theorem, which is a vector identity and is equivalent to the curl theorem. This theorem states that a double integral over a region D of the plane is equal to a line integral along the closed curve C. That establishes the bounded D. Situations frequently arise in which a person needs to measure the area of a two-dimensional space bounded by a closed curve. For instance, cartographers draw topographical maps that show the contours of different elevations or attempts to represent part of the landscape with irregular boundaries, such as forest. The first Green's theorem explanation of why a planimeter works appears to have been given by Ascoli in 1947.
Analyze. With integral, we can find the area of irregular and regular shape by taking different parts of the surface and calculating the area. The planimeter function is a determiner the shape bounds.
The planimeter is based on Green's theorem, which is a vector identity and is equivalent to the curl theorem. This theorem states that a double integral over a region D of the plane is equal to a line integral along the closed curve C. That establishes the bounded D. Situations frequently arise in which a person needs to measure the area of a two-dimensional space bounded by a closed curve. For instance, cartographers draw topographical maps that show the contours of different elevations or attempts to represent part of the landscape with irregular boundaries, such as forest. The first Green's theorem explanation of why a planimeter works appears to have been given by Ascoli in 1947. The polar planimeter has the shape of a ruler with two legs, and one leg of length r connects the origin 0, 0 to A, B. The second leg of line r connects to the points A, B with x, y during the measurement process. The planimeter is fixed at 0, 0 and the point x, y is at any time located at the boundary of the region. If x, y is given, then A, B is determined as an intersection point of two circles of radius r around 0, 0 and x, y. After completing the plot along the boundary of the region R, the total wheel rotation indicates the area of the region
Conclusion. The planimeter and the Green theorem have a relation. One helps the other to prove their functions. For some fields, the planimeter helps to make the calculus easier, sliding the device around the shape of the surface, but also the Green theorem is useful when you don't have this type of technology, even if it takes more time to calculate the field.